Okay, we just did this problem. I thought it was an interesting way of doing it. Although some people might find it difficult to do it this way, but I thought it was an interesting way of doing it. And it worked out pretty nicely. We had a nice answer in the end of -1. So what we're going to do is go to question 13 now, which appears to be the same question repeated. So question number 13, it says x plus 1 over x equals root 3. And then it goes on to say, what's x to the 100 plus 1 over x to the 100? What's this equal? All right. So if I were doing this one over here, probably the thing that most people would do first is to solve this equation. And if you did that, what do you get? We multiply both sides by x. You get x squared plus 1 equals root 3 times x, quadratic in form. So it's going to be minus root 3 x plus 1 equals 0. The quadratic form is appropriate here. You get 2 here, root 3, plus or minus. And then what do you get? Let's see, 3 minus 4. Well, that's working out pretty nicely. I get root 3 plus or minus. Square root of -1 is I, and that's over 2. So I'm going to write this a little differently. I'm going to write it as root 3 over 2 plus or minus 1/2 of an I. And I want to remind you that we've been writing these things in polar form. That's the real part. This is the imaginary part. I actually have two numbers. I'll say x1, and x1 is root 3 over 2 plus 1/2 of an I. And the other one, x2, is going to be root 3 over 2 minus 1/2 of an I. And I'm going to say, sort of like this over here, root 3 over 2. And I'm going to say maybe the first one's over here somewhere. And I know that about triangles at this point. It's trigonometry, of course, trigonometry. The theta over here, I'm going to use degrees, is 30 degrees. All right? And then, what's the r over here? Well, how do I get the r? I do this over here. R squared is going to be root 3 over 2 squared plus 1/2 squared. And that's going to give you 3/4 plus 1/4, which is 4/4, is just 1. Pretty simple. All right? So I think I can write down x1 as a complex number in polar form. I'm going to say z1 now. And what's that going to be? Let's see. R, which is 1, times cosine of 30 degrees plus I sine 30 degrees. And I kind of like to write this down as CIS then. CIS 30 degrees. All right? The R is 1, so I'm not going to write that down again. Z2. Well, if I visualize Z2, it looks sort of like this over here. And it's got the angle now is going to be minus 30 degrees. So I think I can write that down pretty quickly, by the way. Cosine minus 30 degrees plus I sine minus 30 degrees. All right? We can also write this down as CIS, which stands for cosine of theta plus I sine of theta. And that's going to be minus 30 degrees. All right? So what do we got to do? I got to figure out what the 100th power of it is. And you're going to use de Moivre's theorem to do it. So z1 to the 100th power. It's not easy to write down, but I guess I could write it down, right? So it's going to be, 1 to 100th. That's r being to the 100th power. And then CIS of 30 degrees times 100. That's a nasty looking number, isn't it? 1 times is just 1. So I get CIS, and that's going to be 3,000. All right? That looks pretty nasty, but we'll get back to that later. I'm going to put down Z2 to the 100th power. What's it going to be? 1 to the 100th times CIS minus 30 degrees times 100. And that's going to be, 1 times CIS minus 3,000. Well, I got 3,000 to worry about. And what I want to do is just talk about it. And I got to say, how many times does it go around? I got to figure that out, don't I? So 360 degrees times 8. All right, let's take a look at that. That's 0. 8 times 6 is 48. 8 times 3 is 12. And, I'm sorry, I misspoke over there. I'm daydreaming. 8 times 3 is 24, 28. Well, that's not so bad. So CIS 3,000 Well, I'd go around 8 times, and then I'd have something left over. And how much would you have left over? Well, let's see. To get to 3,000 would be. I'm not gonna write 3,000 down again. Let me get my eraser out. I'm going to say 120. Okay? So that's not so bad. I think I can do that. And I'm going to put it back in the Z1 to 100. I'm going to write it as x to the 100 now. And I think I know what that is, by the way. And looking at it, let me get my eraser out and erase this business over here. 120 degrees. And I know, let's see, 120. I'm going to be careful now. Let's take a look. The R is 1 still, and 120 is in the second quadrant. And I'm getting, I didn't really do a very good job at drawing that picture, did I? Let me draw it again. Actually, let me put the axes down for you. The reference would be 60. This is 120 degrees. Reference is 60 here. The R is 1. This would be 1/2. This would be root 3 over 2. So I can write this down now. What's it going to be? Let's see, minus 1/2. I'm seeing that there, by the way. And then it's going to be plus root 3. By the way, this is the real, and this is the imaginary. So root 3 over 2i. All right? So I think I can write this down now. And so I'm going to say x to the 100 plus 1 over x to the 100. Let's write this down. So it's going to be minus 1/2 plus root 3 over 2i plus, here comes the tough one, 1 minus 1/2 plus root 3 over 2i multiplied by minus 1/2 minus root 3 over 2i minus 1/2 minus root 3 over 2i. A lot of arithmetic, isn't there? Minus 1/2 plus root 3 over 2i plus, what's going to be minus 1/2 minus root 3 over 2i. What do you get on bottom? You'd get what? It's conjugates, right? So it's going to be 1/4, then you're going to get plus 3/4. Well, that's 1, isn't it? So I'm left off with something pretty simple now, all right? And this is what we're looking for. It's going to be minus 1/2 plus root 3 over 2i minus 1/2 minus root 3 over 2i. Let's see, these cancel off. We still get minus 1. That one's done, all right? We're getting the same answer. Let's do this one over here. And it's really the same story. I mean, I'm looking at this thing, but I'm rotating in the other direction. And, 8 times around, then minus 120. I'll put this over here. And minus 120 is going to look like this over here. This is minus 120. This is 120 degrees, by the way. And it's really the same story. What do you get? Put this down. It's going to be Z2 now to the 100. That's going to be, I'm still getting the minus 1/2. And now I'm getting minus root 3 over 2i. All right? So I'm going to do the same thing twice. And this is going to be x 100 again. We already did this one. Now we're doing this one here. All right? Let's write that down. So we're going to write x to the 100 plus 1 over x to the 100. That's going to be minus 1/2 minus root 3 over 2i plus 1 over minus 1/2 minus root 3 over 2i. Multiply top and bottom by the bottom's conjugate. Minus 1/2 minus root 3, plus minus root 3 over 2, minus 1/2 plus root 3 over 2i. What do you get here? Minus 1/2 minus root 3 over 2i plus, we get minus 1/2 plus root 3 over 2i. On bottom, what do you get? You get 1/4 plus 3/4 again, which is 1. Isn't that pretty easy? What is it? Minus 1/2 minus root 3 over 2i plus minus 1/2. Well, let me just cross that out. Let me get my eraser out again. All right, where was I? Oh, minus 1/2, and then it's going to be plus root 3 over 2I. What happens over here? These two cancel off, and minus half is minus 1. All right, so it's leading to the same thing every single time, by the way, which is good. I mean, basic algebra that we use led to minus 1, and now using de Moivre's theorem also led to minus 1. Thank you for paying attention.